Okay, so for our next topic for today's discussion is regarding motion curves. So last time we already discussed or analyzed non-uniform acceleration motion of a certain body or particle by the aid of calculus. No. So now we will analyze non-uniform acceleration motion also, but by graphical solution. So as the name implies, for our topic, we will just graph the curves of motion of the particles or body. And that is by the aid of the properties of areas. No. So here, when a particle has erratic or changing motion, then its position S, velocity v, and acceleration a cannot be described by a single continuous mathematical function or equation along the entire path. So kapag pabago-bago yung motion, magkakaroon tayo ng madaming equations na i-derive or i-integrate. So that is summation of integral of, summation of the derivative. So, instead mismo na mag-integrate tayo or mag-derive tayo ng madaming function or equation, we will just represent the motion of the particle or body in terms of graph. No? And yun i-analyze natin mismo para makuha natin yung position niya, yung velocity niya, and yung acceleration niya. Okay. Assuming meron tayong acceleration as a function of time, meron tayong equation. And that equation, po pwede natin siyang i-graph. Ito yung curve niya. And if we want to know the area bounded by this curve, with respect kay acceleration axis and axis ng time, medyo mahihirapan tayo. No? Dahil equation mismo itong curve natin na yan. So, anong ginagawa natin? Nag-a-assign tayo ng differential strip or rectangular strip. And that rectangular strip will represent the whole area bounded by this acceleration as a function of time. No? And with respect to that acceleration as a function of time, kapag i-integrate natin yan, makukuha natin si velocity as a function of time na equation. Since meron tayong equation, pwede natin i-graph yung curve ng equation na yon. Again, if we want to know the area bounded by this velocity as a function of time with respect kay axis ng velocity and axis ng time, medyo mahihirapan tayo ulit. So, anong ginagawa natin ulit? Mag-a-assign tayo ng rectangular or differential strip at yun yung magre-represent ng whole area na nag-bound mismo, binabound nitong velocity as a function of time na curve. Now, using our kinematic differential equation, first one, we have the A equivalent to dv over dt. If we will cross-multiply, derivative of velocity or dv is equivalent to A dt. So, na-separate na natin yung variable ng velocity and time. Kapag na-separate na natin, we are ready to integrate both sides of the equation. Siyempre, maglalagay tayo ng limits. Yung limits na ilalagay kung saan natin mismo kinukuha yung area. For this figure, kukunin daw nating area with respect sa time boundaries, initial time hanggang final time. Ito lang daw. No? Etong area na yan. Gets po? And then, integrating dv, that is v. No? That is from v1 to v2. Kapag i-apply nating limits, apply first upper limit, magiging v2 minus apply yung lower limit, magiging v1. v2 minus v1 or final velocity minus initial velocity or that is the change in velocity. Ngayon, yung nasa right side of the equation, integral of a dt from t1 to t2. Ano ba yung a multiplied by dt? A multiplied by dt, that is the area of our rectangular strip. No? Na kapag in-integrate natin yan, yun na yung whole representation ng area ng acceleration as a function of time natin. Ito na yung magiging form ng equation natin. No? That will be our first formula. Wherein, final velocity, nakaproject yan kay final time. Ito na si v2. Yung v1, nakaproject doon kay initial time. Ito na si v1. Nakapag gusto nating makuha yung v2, ililipat lang natin sa kabila. That is v1 plus the area of acceleration versus time graph. Ito daw si V1, tapos ipa-plus natin yung area dito, nandun na tayo kay V2. Looks familiar, di ba? Yung process. Dahil yung process na yun, ginawa nyo na rin or ginamit nyo na rin kay mechanics of deformable bodies under the topic of shear and moment diagram. So dito, nag-iba lang yung mga variables na ginagamit natin. Okay, so that will be our first formula. And then, using another kinematic differential equation, V equivalent to ds over dt, by cross multiplication, ds will be equivalent to v dt. Na-separate na natin ulit yung variable ni displacement at saka ni time. So, you are now ready to integrate both sides of the equation. Maglalagay tayo ulit ng limits, no? From initial time to final time, initial position to final position. Yung limits natin na yon, depende kung saan natin kinukuha yung area natin, no? Okay. Now, what is the integral of ds? That is s. From S1 to S2. Applying the limits, that will become S2 minus S1. Tama? Or change in position or the displacement. Gets po? Ngayon, yung nasa right side, equivalent to the integral of v dt from t1 to t2, ano ba yung v multiplied by dt? V multiplied by dt, that is the area of rectangular strip, na kapag in-integrate natin yun from T1 to T2, that will be the area of velocity versus time graph. No, that will be our second formula. Final position minus initial equivalent to the area of velocity versus time graph. Kapag gusto natin kunin yung final position, lilipat lang natin to S1 plus area of velocity versus time graph. So, yung T1 tsaka T2 na yan, nakaproject din dito kay displacement as a function of time na graph. T1, nakaproject kay S1. Yung T2, nakaproject kay S2. No? Para makodo natin S2, that is S1 plus the area of velocity versus time graph sa taas niya. No? And then, another one, we have the next formula for the change in position. No? So, yung kanina, change in position din. So, for this, change in position din. So, ano yung pagkakaiba nila? Okay. For this formula, nakuha natin kay formula ng change in velocity. Change in velocity is the integral of a dt from t1 to t2. No? Itong formulang ito. So, using that will be change in velocity or final velocity minus initial velocity. That is the integral of a dt from T1 to T2. Ito yung area ng acceleration versus time graph. No, di pa lang natin siya nirepresent as an area. So, ginawa pa lang siyang integral. Okay, now, kapag gagawin natin variable v, yung final velocity natin, that will become v minus v1, integral of a dt, t1, palitan din natin yung variable ng final time, make it t only. No, corresponding to the final velocity variable. No, etong dalawang equation na yan, dalawang formula, parehas lang yan, guys. Iniba lang natin yung variable. Ang ibig sabihin ng V2 tsaka V, final velocity. Ang ibig sabihin ng T2 tsaka T, final time. So, parehas lang. No, so ilipat natin yung V1 sa kabila. V will become V1 plus integral of a dt from T1 to T2. O from T1 to T. Naging variable na t na siya. But velocity v has a kinematic differential equation that is equivalent to ds over dt. So by cross multiplication, that is ds equivalent to quantity v1 plus integral of a dt from t1 to t multiplied by dt. Ito na tayo. No? So, na-separate na natin yung variable ng displacement tsaka time. You are now ready to integrate both sides of the equation. From T1 to T2, from S1 to S2. No? And then, yung nasa right side, integral ng dalawang term, multiplied by dt. So, i-distribute lang natin yung integral sign sa bawat term tsaka yung dt. So, maging integral siya ng v1 dt from T1 to T2 plus integral of the quantity, integral of a dt from T1 to T, dt from T1 to T2. No? So, you are now ready to integrate. Ano integral ng ds? That is s. From S1 to S2. Kapag in-apply natin limits, that will become S2 minus S1. Or change in position. Ito naman, ilabas natin yung V1 dahil constant term yun. So, V1 multiplied by integral ng dt. No? V1, ano integral ng dt? T. From T1 to T2, pag in-apply natin yung limits, ito yung magiging form. V1 multiplied by T2 minus T1. No? Ito namang naka-plus dito sa right side of the equation, double integral, di ba? And that double integral is the moment of area. The moment of area from or projected to the final time. No, i-moment lang daw natin yung area ng acceleration versus time graph sa final time. No, or that is the product of the area of acceleration versus time graph and yung distance ng centroid ng area na to papunta kay final time. So, that is another formula for the change in position. So, meron tayong dalawang formula for the displacement. Yung displacement po pwedeng naka-express in terms of area of acceleration or yung displacement naka-express in terms of the area of velocity. So, mamaya ipapaliwanag ko po mismo kung ano yung kaibahan ng dalawa. Kung kailan natin gagamitin to formula na to at kung kailan magagamit yung formula na ito. So, yun lang po. Tatlong formula po yung gagamitin natin. Isang formula ng change in velocity and dalawang formula ng change in position. So, iikot lang tayo dun, guys. And also, you need to familiar yourself with respect to these properties of areas. No? So, sa curve ng ating motion ng particular body, usually ito yung mga makikita yung graph. No, meron tayong rectangular. Pag sinabing rectangular, 0 degree. Horizontal. No? Meron tayong triangular doon or a first degree curve. Meron tayong parabolic spandrel or second degree curve. Meron tayong cubic spandrel or third degree curve. Pwede rin 4th degree, 5th degree, 6th degree, and so on. No? So, nandiyan na yung mga formulas nila ng area and then formulas ng kanilang centroids. So, memorize nyo na lang yan, guys. No? Para alam nyo yung gagamitin nating formula. Kung ayaw nyo mag-memorize, i-memorize nyo lang yung general form ng area natin. That is BH over n plus 1 and the centroid, that is B over n plus 2. No? Gets po? Where n is the degree of the curve. Kanyari, rectangular. Pag sinabing rectangular, 0 degree. Therefore, n will be 0. So, 0 plus 1 is 1. BH over 1 is BH. Ito na yon. If n is 0, 0 plus 2 is 2. That will become B over 2. Pag meron tayong cubic spandrel, third degree. N is equivalent to 3. So, 3 plus 1 is 4. Magiging BH over 4 yung area. If n is 3, 3 plus 2, magiging B over 5 yung centroid. At yung centroid distance nakaproject sa final point. Nakaproject sa right side ng ating area. No, sa final time axis. Gets po? Okay, so these are your properties of areas. So, iikot tayo dito sa mga formulas na yan at saka yung tatlong formula na present natin kanina. Okay, and that is motion curves. Okay, so let's proceed to problem solving. For this illustrative problem, aralin nyo na lang po yan. So, yung illustrative problem na yun, kapag naintindihan nyo yung process doon, most likely, alam nyo na yung process ng motion curves. Dahil nandun na lahat yung elements kung paano isolve yung motion curve problem natin. Okay, so let's proceed to this activity. For problem number 1, the motion of a particle starting from rest is governed by the acceleration versus time graph as shown below, where acceleration is in feet per second square and t is in seconds. We have to sketch the velocity versus time graph and displacement versus time graph And we have to determine the displacement after 9 seconds or at t equivalent to 9 seconds. So ito yung binigay. At 6 seconds, the acceleration is 12 feet per second square. And at 9 seconds, the acceleration is 8 feet per second square. We have here a first degree curve. And then also a first degree curve. No? Okay. So, ang ating kukunin is velocity versus time graph muna daw. Tsaka displacement versus time graph. So, i-project lang natin yung time natin. 0 seconds, 6 seconds, and then 9 seconds. Let this be axis t in seconds also. Ang una nating maipo-project ay yung velocity as a function of time. No? Or velocity with respect to time. This is in feet per seconds. No? Siya yung una. Siya yung sunod kay acceleration. And then, pagkatapos ng velocity versus time graph, susunod si displacement versus time graph. Okay. So, ito na yung ating curve. Para makuha yung velocity versus time curve, isa lang yung formula ang gagamitin natin doon. Dahil isa lang yung formula ng change in velocity. And that is final velocity minus initial velocity equivalent to the area of acceleration versus time graph. No? So, meron tayong dalawang area dyan, di ba? The area from 0 to 6 seconds and the area from 6 to 9 seconds. No? So, analyze natin separately. From 0 to 6 muna tayo. So, velocity final is the velocity at 6 seconds minus velocity initial is the velocity at 0 second. Equivalent to the area of acceleration versus time graph from 0 to 6 seconds. Ano ba yung velocity at 6 seconds? Kinukuha natin yon. Ano yung nakaproject dyan na velocity at 6 seconds? Minus velocity at 0, may sinabi ba sa problem? Is starting from rest. So, pag nag-start from rest at time equivalent to 0, the velocity is 0. Worst case scenario, kapag walang sinabing starting velocity, starting acceleration, or starting position, make it always na nag-start tayo kay origin. Nag-start tayo palagi kay 0. Pag walang binanggit. No? So, dito may binanggit naman, nag-start nga lang sa rest. So, that is 0 also. Equivalent to the area of acceleration from 0 to 6. Ito yung area. Triangular, di ba? So, ano ba area ng triangle? 1/2 base times height. Ano ang base? 6 seconds. Ito. Anong height? Ito. The height is 12 feet per second square. Cancel yung seconds, may natarang isa. So, cancel to. What is velocity at 6 seconds? 1/2 times 6 is 3 times 12, 36. And the unit is feet per seconds. Gets po? So, eto, 36. Nasa taas, positive. Kapag negative, below the axis of time. Gets po? Ngayon, ang tanong, papaano natin i-connect yung dalawang points na to? So, i-base natin sa graph natin sa itaas niya. Eto, first degree. Kapag first degree ito, sunod second degree. Kapag 0 degree ito, sunod first degree. Kapag second degree ito, third degree ang sunod. So, nadadagdagan lang tayo ng 1 degree. Gets po? Okay, so first degree, dapat second degree, curve. So, hindi natin alam yung curve natin dito is a happy curve or a sad curve. Hindi ba siya maumbok or maumbok? No. So, paano natin malalaman yon? I-base natin ulit dito. Starting point is 0. Final point is 12. Nag-start tayo kay 0, nag-start tayo kay minimum point. Dahil mas maliit yung 0 kay 12. No? Since nag-start tayo kay minimum point, dapat ang ma-generate nating curve dito ay minimum curve. Minimum point, minimum curve. Pag maximum point, maximum curve. Gets po? Minimum point tayo, dapat minimum curve. So, para maging minimum curve, happy curve. No? Paganyan tayo. Bakit happy curve? Dapat minimum daw yung area ng ating curve. Ito yung minimum area of the curve na tinatawag with respect to the axis of the first point. Gets po? Dahil kapag sad curve yan, pag ganyan, medyo maumbok masyado. maximum yung area ng ating curve. No, so that should be minimum. That is second degree. Gets? Okay, so that is 36 feet per seconds. Okay, sunod, from 6 seconds to 9 seconds. So, ano magiging final natin ngayon? Velocity at 9 seconds. Minus, ang magiging initial natin ngayon is at 6 seconds. Equivalent to the area of acceleration versus time from 6 seconds to 9 seconds. No? So, velocity at 9, kinukuha natin yan. Minus velocity at 6, na-compute na natin. 36. Equivalent to the area from 6 seconds to 9 seconds. Ito yung area na kinoconsider. Trapezoidal. No? Ano ba yung formula ng area ng trapezoid? That is mean height or average ng height multiplied by the base. No? Kung hindi nyo alam, yung area ng trapezoid po, pwede naman nating hatiin dito. Hatiin natin horizontally dyan, meron tayong triangle sa taas, meron tayong rectangle sa baba. Or po pwede nating hatiin dito. No? Pag hinati natin doon, meron tayong makikreate na dalawang triangle. Gets? Okay. So, hatiin natin dyan. Assume natin hindi natin alam yung area ng trapezoid. So, hinati natin sa dalawang triangle, dalawang 1/2 base times height. Yung nasa taas muna. So, 1/2 the base. Anong base? Ito. Horizontally. And that length is 3 seconds. Multiply by the height. Ano yung height nun? Ito. No, ano ba yung height na yan? 12 feet per second square. Plus, yung area ng triangle sa baba. That is 1/2 base times height. Ano yung base? Ito. That is also 3 seconds. Ano yung height? Ito. No. And that is 8 feet per second square. Okay, so we're done with the area. So, transpose nyo to, magiging positive sa kabila. What is the velocity after 9 seconds? Kindly compute po. Ano po yung value?
66 po.
Okay. Positive, negative?
Positive
Okay.
po.
Positive 66 feet per seconds. So, tumaas. Mas mataas kay 36. Ngayon, ang tanong, paano natin i-connect yung dalawa? No? Okay. Bibase natin sa graph sa taas. Nag-start tayo kay 12. Magtatapos kay 8. So, starting point is a maximum point. So, dapat, ang ma-generate nating curve ay maximum curve. Paano ba tayo makakabuo ng maximum curve? Dapat siya ay sad curve. No? Dapat mas maumbok. With respect to this axis of first point, itong tinatawag nating maximum area of the curve. Kapag minimum curve yan, happy curve, minimum area. Medyo hindi tayo nag-conform dito. Dapat maximum. Nagigets po ako dun, guys. First degree to, second degree. No? So, we're done with velocity as a function of time. Ang sunod, displacement as a function of time. So, i-project din natin. Naka-project. Axis ng time in seconds. And axis ng displacement in feet. So, analyze muna natin motion from 0 to 6. Okay, so, ang gagamitin natin formula, change in position. No? So, para magamit yon, meron tayong dalawa doon, di ba? So, gamitin natin dalawang formula and then, i-compare natin yung sagot na makukuha natin with respect sa dalawang formula na yon. So, yung una muna, change in position equivalent to the area of velocity versus time graph. So, final position minus initial position equivalent to the area of velocity versus time. From 0 to 6, ang magiging final position is position at 6 seconds. Initial position is at 0, equivalent to the area of velocity versus time graph from 0 second to 6 seconds. No? Ano ba yung position at 0? May binanggit ba sa problem? Wala. So, we will assume na mag-i-start tayo kay 0. So, this is already 0. So, position at 6 seconds, naka-project yung 6 dito. Ano yung value dyan? Equivalent daw kay area ng velocity from 0 to 6. So, tingnan natin yung area ng velocity versus time graph from 0 to 6 seconds. Ano to? Parabolic spandrel. No? Yung hindi maumbok. The minimum area of the parabolic spandrel. Ano ba yung area formula? Pag di natin memorize, dapat memorize nyo po yung general form ng area. BH over n plus 1, where n is the degree. Ano bang degree? Second degree, therefore, 2 plus 1 is 3. No? Ito guys, ang iisipin nyo. Pag meron tayong rectangle, ito yung curve natin. If that curve is second degree, ito yung minimum area, ito yung maximum area, yung maumbok. Ito ay BH over 3. Yung maximum area is 2BH over 3. Ngagets po. Kapag third degree naman, ano yung n natin? 3. So, magiging BH over 4. Yung BH over 4, yun yung area formula ng minimum area of a third degree curve. Ito naman ay maximum area ng third degree. 3BH over 4. Bakit ganyan? Dahil kapag plinas natin yung 3/4 tsaka 1/4, equivalent kay 1. 1 times BH is the area of rectangle. Dito din, 2/3 plus 1/3 is equivalent to 1. So, pag pinag-plus nyo yun yung area ng rectangle, which is BH. Gagets po? Eh, saan ba tayo? Minimum area of a second degree curve. Ito tayo. BH over 3. Ano ba yung base? Analyze natin. Ito yung base, di ba? And that is 6 seconds. Ano ba yung height? Ito yung height natin. 36 feet per seconds over 3. So, 6 over 3 is 2 times 36, 72 feet. No? That will be our position at 6 seconds. So, i-check naman natin yung sagot using yung isang formula ng change in position. Ano ba yon? S2 minus S1 equivalent to V1 times T2 minus T1 plus the area of acceleration versus time graph multiplied by the distance of its centroid projected to final time. Okay, so from 0 to 6, this is S6 minus S0. Initial velocity at 0 second. Anong final time? 6 seconds. Minus, anong initial time? 0. Plus, area ng acceleration versus time graph multiplied by the distance of centroid projected to final time, which is 6 seconds. No. Again, position at 0 second is 0. S6. What is the velocity at 0 second? Ito. Velocity at 0 second is 0. So, cancelled. So, area ng acceleration multiplied by the distance of its centroid na nakaproject kay final time. So, ibibase natin yung position sa area of acceleration naman ngayon. Tingnan natin yung acceleration versus time graph. Ito tayo. From 0 to 6. The area of acceleration is area of triangle. And then, imumultiply daw natin yung distance ng centroid ng triangle na yan na nakaproject kay final time. Nakaproject kay 6 seconds. So, yung distance daw na yan. No? Ano yung distance na yan? So, dapat memorize nyo yung centroid formula natin. No? Ano ba yung centroid formula? B over n plus 2. No? Ano bang n? The degree of the curve. That is 1. First degree. So, B over 3. No? Kapag yung centroid papunta sa mas malaking part ng triangle, ito yung triangle natin, di ba? Ito mas malaki kaysa dito. Kapag yung centroid papunta sa Kapag yung centroid ay papunta sa mas malaking part ng triangle, that is 1/3 of the base, or b over 3. Kapag yung centroid papunta sa mas maliit na part ng triangle, that is 2/3 of the base. No? Kaya to b over 3. Ano ba yung base natin? Ito, 6 seconds. So, 6 over 3. So, balik tayo kay formula. So, this is area of acceleration daw. Triangle, 1/2. Yung base. Ano yung base kanina? 6 seconds. Ano yung height? 12 feet per second square. Imumultiply daw yung distance ng centroid niya. Papunta kay 6 seconds. That is b over 3. Ang base ay 6 over 3. No? So, cancel to. Cancel yun. Natira 12 times 6. Which is also 72 feet. So, na-confirm natin na yung position at 6 seconds is talagang 72. Positive, nasa taas. No? Ang tanong ulit ngayon, papaano natin i-connect yung dalawang point na to? Again, magbe-base tayo sa curve na nasa itaas niya. Yung point na to ay 0. Magtatapos kay 36. So, starting point is a minimum point. Therefore, dapat minimum curve. Paano tayo makakabuo ng minimum curve dito? Happy curve or sad curve?
Curve.
That should be a happy curve. No? Pag second degree yon, ito ay third degree. And then, ito ay 72 feet. Okay, so tapos na tayo kay 0 to 6. Sunod, 6 seconds to 9 seconds. Change in position pa din. Okay, gamitin muna natin to. Anong final natin ngayon? Position at 9 seconds. Minus, anong initial? Position at 6 seconds. Area ng velocity versus time graph from 6 seconds to 9 seconds. No? Ano yung position at 9? Wala pa tayo. Minus, position at 6, na-compute na natin. 72 feet. Kaya kapag mali kayo dyan, medyo domino effect. No? Dapat from the start pa lang, medyo tama na yung sagot natin. Area ng velocity versus time graph from 6 seconds to 9 seconds. Tingnan natin yung velocity. Velocity versus time graph from 6 seconds to 9 seconds. Ito yun. Tama? Meron tayong area ng rectangle tsaka area ng parabola. No? Area ng maximum curve ng parabolic spandrel. Tama? Ano bang area ng rectangle? Base times height. Ano ba yung height nito? 36. Tama? Ano bang area ng parabola? Second degree. Yung maximum, ito, 2/3 base times height daw. Tama? Ito yung base. Ito yung height. Ano yung height niya? 30 feet per seconds. 66 minus 36 is 30. Kapag pinag-plus natin to, that is a total of 66. Okay, so area ng rectangle, area ng parabola. Okay, so lagay natin dito. Yung rectangle muna. Base times height. Anong base? 3 seconds. Anong height? 36 feet per seconds. Plus, yung area ng maximum parabola. 2/3. Base is 3. A height is 30 feet per seconds. So, we're done with the formula. So, transpose mo lang tong negative 72 magiging positive sa kabila. Ano yung position after 9 seconds? Kindly compute po. 240 feet. Okay, may nakuha na tayo. Ngayon, i-check naman natin yung position at 9 seconds using itong mas mahabang formula na to. Final position, yung position at 9. Minus initial position, position at 6 seconds. Equivalent to initial velocity, velocity at 6 seconds. Multiplied by T2, final time. Ang final time, 9. Minus T1, initial time, 6. plus the area of acceleration versus time graph multiplied by yung centroid, distance ng centroid ng area na to na nakaproject kay final time, which is 9 seconds. No? Okay, so substitute. S9 is unknown minus S6, na-compute na natin yon 72. Equivalent to velocity at 6 seconds, V6. Na-compute na natin yon. The velocity at 6 seconds is 36. Ito. No? So, substitute. This is 36 times 9 minus 6 is 3 plus area daw ng acceleration from 6 seconds to 9 seconds. And then nakamultiply yung distance ng centroids nila. Okay. Analyze natin yung acceleration versus time graph. Ito tayo ngayon. From 6 seconds to 9 seconds, ito yung area. Trapezoid ulit. Pwede nyo gamitin yung area ng trapezoid provided that alam nyo kung nasaan mismo yung centroid location ng ating trapezoidal area. Pag hindi, hatiin nyo. Dahil yung present natin kay table of properties of areas, meron na tayong centroid distances ng triangular tsaka rectangular. No? Then second degree, third degree, and fourth degree, and so on na curve. So dito, dalawang triangle, yung ginawa natin kanina, gamitin na natin din ngayon yan. So ito yung centroid ng isang triangle. Ito naman yung centroid ng isang triangle. No? Ano yung distances ng centroids na yan papunta kay final time, 9 seconds. So, kunin lang natin distance na yan. Tsaka yung distance na to. No? Ito munang area na nasa taas na triangle. Yung centroid papunta sa mas maliit na part ng triangle. Ito yung maliit at yung malaking part, di ba? So kapag yung centroid papunta sa maliit na part ng triangle ay 2/3 of the base. Ito naman, yung centroid ay papunta sa malaking part ng triangle. Ito yung maliit na part. Zero tayo doon, di ba? So pag papunta yung centroid sa malaking part ng triangle, that is 1/3 of the base. Ano ba yung base natin? From 6 seconds to 9 seconds, that is 3. So 2/3 of 3, that is 2. 1/3 ng 3, that is 1. Tama? So yan yung i-multiply natin sa area nila. No? So anong area nito? 1/2 BH. Anong area nito? 1/2 BH. So, substituting sa area natin, sa formula, yung nasa taas muna, area is 1/2 base of 3 seconds. Anong height? 12 feet per second square. Anong centroid distance niya? 2 seconds. Plus, yung nasa ibabang area, 1/2. Anong base? 3 seconds. Anong height? 8 feet per second square. Ano yung distance ng centroid niya? Papunta kay final time? 1. No? So, transpose nyo lang yung negative 72, magiging plus sa kabila. What will be the position of the particle after 9 seconds? Kindly compute to, guys.
228.
228 feet. Okay, compare natin dito. Oops! Bakit ngayon, sir, hindi na sila parehas? Kanina, parehas. So, ano po yung gagamitin nating value? Okay, take note of these, guys. Okay. So, yung isa, gumamit tayo ng area ng velocity. Yung isa, gumamit tayo ng area ng acceleration. No? For this area of velocity, yung 6 seconds to 9 seconds, yung area na to ay second degree curve. No? Ngayon, itong second degree curve, pangalawang second degree curve na siya kay velocity versus time curve. Ito yung nauna. No? Pag unang second degree, third degree, unang fourth degree, unang fifth degree, and so on, okay lang na gamitin yung dalawang formula. Parehas lang po yung makukuha nating sagot. No? Pag pangalawa, pangatlo, pang-apat, pang-anim, pang-lima, and so on, na second degree, third degree, fourth degree, fifth degree, and so on, hindi na po pwedeng gamitin yung formula ng change in position na gamit yung area ng velocity versus time graph. Hindi na po ito po pwede. No? Again, ulitin ko, pag pangalawa, pangatlo, pang-apat, and so on, na second degree, third degree, fourth degree, and so on, hindi po pwedeng gamitin yung formulang ito. Ang mag-govern na area or formula ito, gamit yung area of acceleration. No, etong mahabang formula nito, wala po tayong restrictions dyan. So, I suggest, ito po yung gagamitin nyo palaging formula when it comes to second degree curve, third degree curve, fourth degree curve, and so on. Pag first degree, wala tayong restrictions dito sa formulang ito. Pag 0 degree, wala din. May restrictions lang to sa pangalawa na second degree, third degree, fourth degree, and so on. So, hindi siya po pwedeng gamitin sa pag-analyze. So, ano mag-govern na value? Yung nakuha natin gamit itong mahabang formula, which is 228. No? So, yun po yung gagamitin natin ito. Hindi po siya po pwede. So, the position at 9 seconds is 228. No? Ang tanong pa, paano natin i-connect to? Is it a happy curve or sad curve? Yes po? Happy curve or sad curve, guys? Sad curve
po.
daw. Titingnan natin, analyze
Happy.
natin. Nag-start tayo kay 36, magtatapos tayo kay 66. So, starting point is a minimum point. No? Therefore, ang sunod dapat ay minimum curve. So, paano ba tayo makaka-generate ng minimum curve? That should be a happy curve.
Happy.
Gets po? Wala nang kinalaman yung pagkaumbok niyan o kaya hindi pagkaumbok. Nagbe-base po tayo palagi sa point na pinag-uumpisahan. Kung maximum ba yan or minimum. Nagets po? And that will be the graph of displacement versus time curve. No? So, nasagutan na natin yung problem natin. And then, the last requirement, okay na to, okay na yan. Displacement at t equivalent to 9 seconds or S9, the answer will be 228 feet. Questions, guys?